Hi, and I'm Ms. Nowicki, and welcome to the first lecture called What is Science? The learning objectives for this lecture are: describe the goals of science, explain the procedures that are the core of scientific methodology, define what a scientific theory is. The nature of science. Science is a process. I think everybody gets kind of all up in arms or up thinking science is something complicated. Okay, but what science is a way to generate a knowledge and understanding and generate it not based on just what is my story or what is your story, but looking at large, what's the word I'm looking for? Large patterns. Okay, looking at data to see what happens with science is we're using evidence, okay, and we're taking evidence from different areas to construct testable explanations and then predictions of natural phenomenon. Okay, so we're using that to actually figure out what is going on in the world. But we're not taking it based on just what I see in my day or what you see in your day. We're looking at hundreds of days, okay, or thousands of days, depending on whatever we happen to be testing. Scientific methodology is a general style of investigation. Now, you guys have probably learned the scientific method. And the scientific method is great. However, I think teachers have maybe drilled into your heads that it's some sort of step-by-step process that you go here, then you go here, then you go here. And that's not necessarily the case. What science is about is it's about observing things and then asking questions about those observations. That's the basis of science, is we see something, okay? In this picture, we see location A, okay, where we have shorter grass, and we see location B, where we have taller grass. Why is there a difference? Okay, so that's the observation, location A, shorter grass, location B, taller grass. The question, I wonder why that is. Why is that the case? Okay, and so what science does is it allows us to take that question and move on and go through a variety of steps to try and answer that question. That's all science is about. It's trying to find the answers to questions. So then we take that observation, we take that question, and then we make a hypothesis. Okay, so the question is, why do marsh grasses grow to different heights in different places? Okay, our hypothesis is, okay, and the thing about a hypothesis, all right, is that we have to be able to test it. So our hypothesis is maybe a location, remember this is A, and this is B. Whoop, that was a terrible B. All right, and this is B. Okay, maybe B has more nitrogen. Okay. So an inference is a logical interpretation, and a hypothesis is a tentative scientific explanation. They go hand in hand. But an inference is actually our interpretation that can lead us to the hypothesis, because the big thing here is an inference is an interpretation based on what we already know. So this is based on those observations or previous studies, okay? Depending on what you happen to be studying. If you're looking at a new medication for something, we can take information from old medications and use that to the next step to build a new medication. A hypothesis is a tentative scientific explanation that can be tested. That's the important part about a hypothesis. It can be tested. Okay. Some hypotheses will be tested via more observations or analysis. So some may be tested by actually running experiments. It all depends. But the hypothesis has to be able to be tested. Testing hypotheses often involves designing experiments that measure factors that can change, or what are called variables. So in this experiment, we're talking about how grass grows. Our hypothesis is the fact that location B had more nitrogen. So our control group, okay, we have no nitrogen, all right? And then in our experimental group, we're going to add nitrogen. Okay, so nitrogen, or the amount of nitrogen, is actually the variable. That's what we're changing, the amount of nitrogen. Okay. So when we can actually collect the data, right? And depending on your experiment, it may be data for a day, a week, an hour, a month, years, all depends. Okay, so we look at the data and we can do a couple of different things. We can get two types of data. There's qualitative and there's quantitative. So quantitative data are actually numbers, quantity, quantitative. So the measurement on the ruler is actually going to be quantitative data, how tall the grass actually grew. Qualitative is descriptive, the quality of the specimen that you're looking at. So maybe when it comes to this grass experiment, maybe you could talk about the grass's color. That would be qualitative. Greener grass or browner grass. Texture, okay, how thick it is. All right, those are all qualitative measurements. Then what we do is we actually analyze those conclusions, okay? And so we use data analysis, most often in the form of statistics, which is just a type of math. Not that we're going to get too much into it, but it's a special type of math that tells us how far our numbers are different and if there's an actual difference between them. And so what we do is we actually look at the data, and here we can see there's a huge difference. Whoops. There's a huge difference between how tall the grass grew, okay, for the control versus the one with the added nitrogen. So location A versus location B. And statistics is just a type of math that actually tells us how big that difference is and how important it is. That's all statistics does. Okay, but just by looking at this, we can see that huge difference, and it's like, oh, so I guess the nitrogen did make a difference. Okay. Last but not least, scientific theories. Now, there's a lot of talk about what a theory actually is, what it actually means. When you use a theory, the word theory in conversation, or if somebody's talking, I have a theory, okay? That's just an idea, okay? In science, however, the word theory actually applies to a tested and highly reliable scientific explanation of events in the natural world that unifies many repeated observations and incorporates durable, well-supported hypotheses that enable scientists to make accurate predictions. Okay, so this is actually really, really, really important when we think about the theory of evolution, when we think about the theory of relativity. Not that we're really going to talk about all of these, but theories in science, when they're actually labeled a theory, that means they have a lot of evidence and a lot of support behind them. They're not just some idea that somebody cooked up that we're still trying to figure out. All right, so that's it. Have a great day. Bye.